So in this video, we're going to continue what we just did last when we did an example of quadratics using area and perimeter. And this one's a little bit different in the sense that when you do this, last one we had all four sides of a rectangle. On this one, we're going to look at three sides of the rectangle. So it says, find the maximum area of a rectangular field that can be fenced with 100 meters of fencing if one side of the field is along a river and needs no fencing. So for the most part, this problem is going to set up the exact same way, except this time, we won't need to fence one side of the actual rectangle. So we know that the amount of fencing that we have right here, this 100 meters, is the perimeter again. So I know my perimeter is equal to 100 meters. And I want to find the area, which is equal to the length times the width. And in order to do this, I have to write everything in terms of one of the variables, either in terms of the length or in terms of the width. And we're going to write in terms of the width again. So here's what we know. We know that this side right here is W. And if this side is W, then the other side must be W as well. So from 100, we're going to take away 2W, which means that my length, that length measure, without doing any math, I know that from 100, I'm taking away 2W. And so this side right here has to be 100 minus 2W. Last time we had to divide that by 2 because we had two sides we're looking for, but this time we're not looking for this side. So we'll leave it just like this. And when I do this, now I see my dimensions are for my area is my length times my width. So to find that area again, area is just equal to length times width. And my length is 100 minus 2W. And my width is just W. So again, I'm going to distribute this out. And when I distribute, I get my quadratic that I'm looking for, which is going to be the area is equal to 100W minus 2W squared. And I want to rewrite the formula, so I put the W first. So I have a negative 2W squared plus 100. And again, because this value is negative, I know that I'm going to maximize here. And that's what I want to do. I want to maximize the area. So to maximize that area, again, I'm going to look for the first part. Remember, I need to find the values of the x-coordinate, which is negative b over 2a, and the maximum area is going to be at f of negative b over 2a. So that's just me evaluating at 2a. So here my a is negative 2, and my b is 100. I forgot my W here. Let me go back and put that there so I don't lose that. So when I write this, to find this first part right here, the x-coordinate, x is equal to negative b over negative 2 times 2. So when I do this right here, negative negative makes it a positive, and this is 100. 2 times 2 is 4, so it's 100 divided by 4, which is just 25. So I know the x, or in this case, my x is my W, it's my width. I know that this width here is 25. And if that's 25, then this side is also 25. And then to find this, all I have to do is plug it in, 100 minus 2 times W, which should also be equal to 50. Because 2 times 25 is 50. So I know the actual dimensions of the rectangle now. They are 25 and 50. And what I can do to find the maximum area is, the simplest thing would be to just multiply. The area is equal to the length times the width. 50 times 25, or 25 times 50. And when I do that, I get the area equal to 1250. I can verify this measure right here by plugging back the maximum value, when the maximum occurs, and that occurs when the width is 25. I can plug that back into this equation here, and I should get the exact same thing. So when I plug the area back into the area formula, I get negative 2 times 25 squared plus 100 times 25. And so this will be negative 2 times 25 squared, which is just negative 1250, plus 100 times 25, which is a positive 2,500. That's really just 2,500 minus 1,250, which is 1,250. And as you've seen earlier, we had that doing it this way here. This way is a lot simpler just to plug into the actual area formula. But you can also evaluate it using the area formula that you created, which is the W variable.